and I'm going to share my screen. And so I have started recording, and I'm going to write on the screen. And if I can can everybody hear me okay?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
I'm taking my laptop and turning it on its side. And let's see. Here's the presentation. And if everything works well, I should be able to draw on the screen. So this is January 13th, 2021. And we're going to first of all just look at the Calculus 1 main page, and I want to talk to you a little bit about it. I want to answer any questions you might have. And then we're going to look into some the intro to differential calculus concepts. These things that we'll talk about in a minute probably will cover enough for you to do the homework fairly easily. And then we're going to work 2 homework problems that had been requested by 2 of our students. Now, first of all, does anybody have any questions?
Yes, sir.
No, sir.
Okay.
No, sir.
Okay, I'm going to now go to my webpage. And this is me sitting in my office down in Swainsboro before I retired. And if you want to, you can read a little bit about some of the things I worked on before I was a dean of the college or dean of the School of Math and Science. I basically was an engineer and worked on satellites and rockets, the space shuttle, undersea high-speed fiber optics. And then the last thing I did before I came to East Georgia was work on the first Wi-Fi. Now over here is our Calculus 115, Math 1540. If you'll just click on this, you can find everything you need for the course except your grade, okay? All the information that you need, this was shown in the intro video, is shown on this page. You can see the syllabus, all kinds of things. Here's the introductory email. Here's our daily schedule. There's a different one for Swainsboro and Statesboro. And then as you get into the course and get ready to take test 1, here's your test 1 practice test. I would try to work it by yourself and then ask questions. You can click on the practice test video. Hello, this is Dr. Brooke. And see how to work it. And if you need any more practice, there are all kinds of practice quizzes here. And so the same thing for test 2, test 3, test 4, and the final. So I would recommend that you bookmark this page and you'll be able to get to everything you need. Okay. To be successful, you need to watch all the videos on schedule. I would suggest you take notes on my notes. do all the homework and ask questions all the way through the class. I will respond very quickly. You need to know how to use a graphing calculator, probably a TI 8384 or the plus versions are equivalent. And then I would like to recommend that you request a tutoring session if you need help. This would be a one-on-one Zoom tutoring. A number of students use this back in pre-cal, and I think it helped them a lot. Please don't hesitate to ask for extra help if you need it. Be sure to work all the practice tests by yourself first, and then watch the videos on how to work the practice test, and you should be in good shape for everything. Now, what I'm going to do next is just talk a little bit about calculus. And it's going to be some of the simplest concepts. The concepts we'll talk about right now will help you work the first bit of homework. Now, here we have a function, y equal function of x. You should be very familiar with functions. You should have seen a lot of this even back in college algebra. But we're going to be looking at this function between x equal x1 and x equal x2. And here is the curve, the function. Now we're going to draw a line between the value at x1 and the value at x2, and that is called the secant line. Now, you should have heard about the average rate of change of a function as x goes from x1 to x2. And the definition is the change in y, which is right here, called delta y, divided by delta x, which is obviously x2 minus x1. So the average rate of change is the change in y divided by the change in x. And if the x1 is the first point and x1 and x2 is h, then this is the average rate of change. And you will have some problems in the first assignment of calculating the average rate of change. This is also the slope of this line. That's a change in y over the change in x. Now, let's look at a similar curve and look at the first point, P, and then look at various other points on the curve, Q1, Q2, Q3, and Q4. As the various Q's get closer and closer to P, the slope of the secant line becomes what we call the slope of the tangent line. So this red line here is the tangent line. And finally, when we have a Q that is so close to P, you can imagine a line here, extended out here, that we call the tangent line. And that is what we will call the derivative, the first derivative. Excuse me, I've got to spell things right. So again, the average rate of change is given by this equation, where h is the difference between x2 and x1, and this is y2 minus y1. You may have seen this written as y2 minus y1 over x2 minus x1. Of course, this is h. So this is called the slope of the secant line. Now we're going to define the first derivative, which is the limit as h gets closer and closer to 0 of the slope of the secant line. If you can calculate this limit, we have the slope of the tangent line, which is the key to finding the first derivative, or what we call the instantaneous rate of change. If you watch the introductory video, we know that differential calculus is all about how fast things change. It could be how fast you're going in your car. It could be how fast you're going in an airplane. It could be how fast one of my rockets was going when we put satellites into space. The speed there was, before they went into orbit, was 17,500 miles per hour. Now we're going to do a thought experiment, and I ask you to answer some questions. Here is the time after we start a trip. Here's a distance from home in miles. So we start at 0 hours, and here we go for 3 miles. I mean, for 3 hours. And I want you to look at this and tell me what is my average speed, or the average rate of change. Anybody got any ideas?
Are those, you said those were miles?
That's right. That's right. That's miles.
66 miles per hour?
How much?
70.
What'd you say?
I will say 70.
Okay. Somebody else said another number.
Yeah, I just, you said a total of 200 miles out of 3 hours.
And now take a look now. Where did we start? What is that point?
20.
Yeah.
Okay. So I started 20 miles from home. Let me make that a little neater. Started 20 miles from home and ended up here. So the average rate of change, we call it ARC, average rate of change, is what? It's the change in the Y divided by the change in the X, right?
Right.
So what's the change in Y?
It's 180.
Okay. And what's the change in X?
Like a little under 3 hours, 3.
It's exactly 3. Started out at 0.
Right.
And then ended up 3 hours later at 200 miles. So what was my speed? Average speed? 60
60.
miles per hour. Now that used to be the speed limit in Georgia. Of course, on the interstates, you can go 70, 75. But anyway, I was conservative and my average speed was 60 miles an hour. So if I got in the car and put the speed control on 60, my path would look exactly like this. It would be a straight line, okay? And you could write an equation for this line as y equals, the slope of this line is 60. And you add 20 because this is the y-intercept. So that's what that line is. And if everybody always went the same speed and didn't accelerate or decelerate, you wouldn't need calculus. You would just need to look at the slope of the line. Okay. Now I'm going to look at another possibility. Now, here's the first line of my travel. And then Jalen, who's on the call with us, I tracked her driving, and she started off here, came here, but followed this path. Okay. So what is Jalen's average speed?
Roughly,
It's
60.
not roughly, you should be able to say exactly.
Exactly 60.
Does everybody agree with that? Is that how fast you were going, Jalen?
I couldn't hear him.
Huh?
I didn't hear him.
Is 60 how fast you were going? Or your average speed? Jalen went 180 miles. Okay, from here to here. And she did that in 3 hours. So her average was 60 miles per hour. Although she started out and she was always behind me until we got 200 miles. I mean, 180 miles. Now, here is, Brandon, you didn't know I had tracked you, did you?
No, no, sir.
Okay, here you are. If you don't mind me using you as an example, here is Brandon, and he starts out 20 miles from home. And in 3 hours, he's at the same spot. What is Brandon's average speed? What do you think your average speed is, Brandon? You have an entirely different path from mine and Jalen's. How far did you go? 180 miles, right?
Yes, sir.
And you did that in 3 hours. So your average speed is 60 miles per hour. So all of us had the same average speed, but we followed different paths. Now, we're going to get into calculus now and answer these questions. Who is going the fastest after 1 hour? Well, let's look at where we are at 1 hour. Well, let me erase that so you can see it. Here's 1 hour. Here's where Brandon is. Here's where I am. Here's where Jalen is. Who's going the fastest?
Brandon?
Yes. Why do you think so, Jalen?
because he's traveled a further distance in 1 hour than the rest of us.
And you remember we said the derivative, which is called the instantaneous speed, is going to be the slope of the tangent line. Now, we're going to talk about how to find the slope of the tangent line in a minute. But if you have a graph like this, you can sort of draw in a tangent line. Everybody agree that's a tangent line? A tangent line only touches the curve at one point. And then my tangent line, since I'm going the same speed, my tangent line is exactly the line I was on. Now here's Jalen's tangent line. Now which of these lines has the greatest slope?
Brandon?
Yes, it is absolutely the greatest slope. And it turns out that Brandon's, if you look at the slope, if you drew this exactly, you'll see that the slope of his line is 80 miles per hour. So at 1 hour, Brandon is going 80 miles an hour. At 1 hour, I'm going 60 miles per hour. And Jalen is really way behind us. And the slope of her tangent line is 40 miles per hour. Okay, now let's go a little further. Let's go 2 hours. Oops, excuse me. At 2 hours, Jalen's here, I'm here, and Brandon is here. Now, who's going the fastest after 2 hours?
Brandon.
Huh?
Brandon.
Okay, now go back and remember we said that the speed, the instantaneous speed, you know, when you're riding down the road in your car, you might have it on speed control and maybe going 60 or 70 constantly. But sometime you're going to accelerate or decelerate, slow down, speed up. And the speedometer shows you your instantaneous rate of speed. Okay. And when you look down and look at your speedometer, that's the derivative. That is the slope of your tangent line. Now, look at and put some tangent lines on here. Here's Brandon's. Here's mine. It sort of stays the same slope. And then here's Jalen's. I'm not drawing it very pretty. But whose slope is the steepest there?
Jalen's.
Jalen. And if you looked at this, you'll see that Jalen has gone very high speed to 80 miles per hour. I'm still at 60. And Brandon has slowed down to 40. Now, I want you to look at this next one. Who is going the fastest after 3 hours?
Jalen.
In fact, she's going so fast she ought to be picked up, right?
Yeah.
That's right. She's going like 120 miles per hour. See, her tangent line looks about like that, Jalen. Mine looks like this. Dr. Brown is going 60. And Brandon, what do you think the slope of his tangent line is?
0.
0. So Brandon has slowed down as he comes into town. And I'm still going through town, going at 60 miles per hour, and Jalen needs to be stopped by a cop someplace because she's going 120 miles per hour and probably even more. She may get up to 200 miles per hour. Does everybody get the idea of the slope of the tangent line?
Yes, sir.
Okay. So let me do something here. I'm going to be sloppy. Suppose I like S be the distance and T be time, and the graph looks like that. So let's examine that. Let's this be miles and this be hours. And we look at a given point here, and my tangent line looks like that. So that's T1. And at T2, my tangent line looks like that. At T3, my tangent line looks like that.
I don't think that window is showing on the screen.
Oh, it's not?
No, sir.
Oh, what are you seeing?
The previous screen.
Okay, hold it a second. You should, what I don't understand, you see the previous screen now?
Yes, sir.
Yes.
What I'm trying to figure out is I just brought up a Word file and was writing on it, and you should be seeing it. What are you seeing? Anything else now?
The browser.
Huh?
Your website.
You are?
We
What are you
see your
seeing
web
now?
page.
Huh?
The screen recording is only showing the browser.
Okay, I'm showing the browser. So if I picked up, let's see, I'm going to stop this share. I'm going to share the screen. Okay, it's not doing, I want it to show anything I put up. You see this?
Yes, sir.
Yes.
Okay. So this is the way somebody was going, okay, in this curve. So at T1, heck, let's start again. Okay, let's do it again. I'm sorry that didn't work like it should have. Can you see this?
Yes.
Yes.
Okay, so suppose you went on this path. At this point, let's see, I have a tangent line that looks like this in red. At this point, I have a tangent line that looks like this. And at this point, I have a tangent line that looks like this. And at this point, I'll look like this. Now, I'm going to high speed here. say that was 100 miles an hour. This might be 60 miles per hour. And at this point, what's the slope of this top line?
0.
So I'm going 0 miles per hour or 0 feet per second. And at this point, where do you think, what's happening here? What's the slope of that line?
It's turning around, going backwards.
Right.
So it's gonna be
absolutely.
negative.
Very good. It's negative. I'm going backwards. And finally, at this point, I've slowed down. I've gone back to 0 miles per hour, and then I start going forward again. Does everybody get the idea?
Yes, sir.
So
Yes,
every
sir.
time you see a graph, you can get an idea of how fast things are changing. It's almost like going up a ski slope or going up a mountain. Okay. Now let's see if I can go back and get back. To the screen and go back here. Here's the example we just did with Brandon and Jalen and myself. And what I have put on here are the actual tangent lines. And this is what you could do. In fact, there's going to be an analytical way to figure out what these are. Anyway, you're going 80 miles per hour. Jalen's going 40. I'm going 60. And then Brandon goes down to 40. I'm still at 60. And Jalen's going 80. And then she's doing 120. And she's going to be arrested. Okay. Now, I had a couple of requests to do some homework problems, so I thought I would finish and doing that. And I've already worked them out, but I'm going to comment on them here. This is problem 2.19, and it says you want to find the slope of the curve given by this quadratic at the point 3 and minus 5 by finding the limit of the secant slope through P. So what I have drawn here is the quadratic. And I've labeled point P, which you can check is 3 and minus 5, and then have labeled a point Q where X is 3 plus H, okay? So we're going to move from here to here and let X change from 3 to 3 plus H. And the value of Y would be the alpha of 3 plus H. Okay, does everybody see the secant line? Okay.
Yep.
Yes.
So we start out, we're a good ways away the way we're drawing it, and we want to figure out what the secant slope is. It's the change in Y divided by the change in X. Well, at 3 plus H, we plug in 3 plus H into the function. And so we get the value of 3 plus H is 3 plus H squared minus 4 times 3 plus H minus 2. And then we subtract, we subtract the value. It started with, which was -5. So we got minus minus 5. And then the delta x is h. Okay. So we want to calculate this value. Don't get worried. You just have to do some simple algebra to expand it. 3 plus 8 squared is 3 squared, which is 9, plus 6h plus 8 squared. And then this is -12 minus 4h. And then we have -2 minus a -5, which gives you a +3. So now we have 9 minus 12, which gives you -3, plus 3 is 0. And so what you have left is 6h minus 4h, which is 2h, and then plus h squared, all divided by h. Now, here is the key to finding the limit as h goes to 0. Notice you can't just plug in h equals 0 because you'd be dividing by 0. But look at the trick here, which you're going to be doing a lot of times. I'm going to factor the h out and get h times 2 plus h divided by h. The h cancels. So the slope of that line is 2 plus h. Now, what do you think the slope of the tangent line is as h approaches 0? Here you can just plug in h equals 0. And what do you get? 2. So we just did our first calculus problem and found out that the slope of this tangent line right here is 2. So now we know that the equation of the tangent line is going to be y equal 2x plus b. And we need to find b so that it goes through the point 3 and -5. So now we plug in 3 and -5. So y is equal to -5 equals 2 times x, x is 3, plus b, and we solve for b is -11. And so the answer is y equal 2x minus 11. Did you follow that? Do you need more explanation?
I followed it.
Okay. So what we just did was calculate a limit of this expression and having h in the denominator is not the problem because there's an h in the numerator that cancels out and causes us not to have a problem of dividing by 0, and that gives us a limit. Okay, we're going to do one more. Here we have the curve y equal x cubed, and we want to find the slope of the curve at 2 and 8 by finding the limiting value of the secant through p. So what I've done over here is I've drawn y equal x cubed. I've labeled the point 2 and 8. And then I've gone up here to a point, the Q, and added h to the value x. So we're looking at 2 to start off with. We're going to 2 plus h. And the value up here, this point, is 2 plus h for x and 2 plus h cubed for y. So the secant slope is 2 plus h cubed minus 2 cubed and divided by h. Now, what is 2 plus h cubed? Do you know how to do that? You could do it like this, right? Which is 4 plus 4h plus h squared times 2 plus h. And you could now multiply all this out. Or you could remember from college algebra that a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b squared plus b cubed. So 2 plus h cubed is going to be this. If you want to, after this session, you can go and just verify that this is this, and then we're subtracting off the 8 and dividing by h. Now, notice the 8's cancel, so the constants are gone away. And what we have is, I'm going to factor an h out. So we have an h would be multiplied by 12 plus 6h plus h squared. And notice what happens, and this will always, always happen. You'll be able to cancel the bad boy on the bottom and not have to worry about h going to 0 and dividing by 0. So that is equal to 12 plus 6h plus h squared. And so what is this as h goes to 0? Excuse me, this is 12 as h goes to 0. So the slope of the tangent line is 12. So now we know the equation of the tangent line is going to be y equal 12x plus b. And we need to choose b so that it goes through the point 2 and 8. So plug in 8 for y, 2 for x, and we get 24 plus b. So b equal minus 16. And so y equal 12x minus 16 is the equation of the tangent line. Any questions on this?
No, sir.
Okay. Now that's what you will be doing. Let me go show you one other thing. It turns out that we will not have to do quite as much. Wait a minute. We will not have to do quite as much multiplying out as we go forward and learn a lot of the rules of differential calculus. For instance, y equal 2x squared plus 5x plus 8. If you wanted to figure out what the slope was at x equal 2, you would have to put x equal 2 in and then 2 plus h and do that subtraction again. You will find out, and you will enjoy that, to find out that the first derivative is actually going to be 2 times 2, which is 4 times x plus 5. So this is the equation of the first derivative, and at x equal 2, for instance, the derivative or slope of the tangent line is 8 plus 5. Just plug in 2. equal 13. So as we get further in, you'll find a lot of neat ways for like this polynomial of calculating the derivative without doing the limit thing. But you're going to be doing the limit thing for probably about another week or two. Any questions?
No, sir.
No,
Okay.
sir.
I want to emphasize that anytime you need some help, ask for a Zoom video conference or ask me a question and I'll get back to you quickly. Okay, I'm going to get ready for the one at 7 o'clock. I wish every one of you the absolute best. I'd like to see everybody make high grades on this. If you don't have any other questions, you guys take it easy.
Thank you.
Yes,
Thank you.
sir. Thank you.
Thank you.
Thank
Thank you.